Hi, I'm Tom. I don't know much about the Air Force, and finding out about it should be a lot of fun.
The Air Force maintains a range of planes and helicopters that all have to be kept in the highest operational state, and that requires careful management and engineering skill. Richard Hughes is the Engineering Officer for 6 Squadron Sea Sprite helicopters and will be showing you how to keep them up in the air.
Good morning, Tom. I'm Richard. Welcome to RNZAF Base Auckland.
Cheers, Richard.
Today we're going through and doing some engineering on base, so if you'd like to follow me and we'll get started.
Sure.
As the Technical Airworthiness Authority, the Air Force maintains the integrity of every aircraft. We don't have a regulating body to do it for us, so it's important that any changes to the aircraft configuration are done in accordance with the NZF policy and that we maintain the aircraft to the standards set out in our maintenance manuals. Now, Tom, this is the tech support cell for the Sea Sprite helicopter. As you can see here, this is a diagram of the helicopter itself. The role that the cell serves is to manage the configuration of the aircraft. That involves all of the parts, components, assemblies, and any other equipment which comes into contact with the aircraft. Another function that we have in the cell here is the vetting of technical manuals. Well, these manuals are crucial for the squadron. All the maintenance that is done on squadron has to be done in accordance with an approved manual, an approved publication. And these are the approved publications here, so any errors in here could potentially create errors in the maintenance on the aircraft themselves.
The first stop for Tom and Richard is a visit to the squadron hangar to get a close-up look at the Sea Sprite.
This helicopter is in service with the New Zealand Navy, however the New Zealand Air Force actually provides the maintenance and support for it. One of the modifications we're working on currently is the introduction of the Mag 58 machine gun and the machine gun mount, and that's one of the things we'll be looking at now. Tom, here we have the M60 machine gun. The project team has decided that we're going to move to the Mag 58 machine gun as it has a better application for us in what we actually do. As part of that, this machine gun mount that you see here has been set up specifically for this machine gun. By changing to a new weapon, we need to redesign this mount. So the next step is to actually go and look at one of these new machine guns and to see the forces and reactions involved with the firing and operation of that weapon. Okay, Tom, here we have the Mag 58 machine gun. Part of this today, we're just going to get an idea and a feel for the operation of the weapon and how it will be used on the aircraft. This is T. He is an armourer in the New Zealand Air Force. He's going to be assisting us today with the operation of the weapon and demonstrating its capabilities. The modification process is quite a long and involved process at times. It starts with a requirement, which can either be an operational requirement, which the aircrew and the operators of the aircraft have said, we want to see an improvement in this area, or it can also be done through obsolescence where a part is no longer available, or we want to get a new increased capability. Scoping is then done to identify the problem, and then we can start working towards the solution. So Tom, as you can see, there's quite a deal of force generated in the recoil of the weapon. That force needs to be reacted through the gun mount into the helicopter. As such, we need quite a stringent design process to ensure that that force is distributed throughout the structural members appropriately.
The metal shop was tasked with coming up with the working prototype of the new mount.
It's attached to the door of the Sea Sprite via these mounting lugs, and it's got a mainframe here which holds the pintle where the machine gun sits into, and it's got a rocking cradle so that they can manoeuvre it about. Yeah, the engineering officer has an important job to ensure that all the structure that is attached to the aircraft will be strong enough so that in an event of an accident, it will be able to handle the impact without breaking off and possibly injuring or killing the pilots or aircrew.
The next step is for the drawing department to convert the prototype in their 3D CAD software.
This is the machine gun mount that you've seen the prototype for, and we've made a technical drawing of it so we can actually make more of these parts for our Air Force.
A good engineering officer is a jack of all trades, if you like. It's somebody who has the academic capabilities for the job, but is also personable, approachable, and has the confidence to lead people in the support of operations.
Sweet Ed. Excuse me,
No sweat.
The drawing is then used as the basis for calculations done in a program called MathCAD.
What we do here, it's quite like a maths problem you do at school. You set out all your variables and your worst case scenario. You then go through an analysis and prove that the structure actually has enough strength to hold the weapon in the worst case scenario. There's a lot of responsibility put on you as an engineering officer. It's important that you make the best decision based on the information available to you, and also drawing the information out of the guys that work on the aircraft.
That's a lot to take in, so Richard takes Tom to the officers' mess for lunch. The Air Force is a social organisation, and the communal meals allow Richard to catch up with pilots and other officers.
What do you reckon, Rich?
It's all good here. I reckon the bolognese. Essentially, the mess culture is quite a large part of the Air Force lifestyle. It gives an opportunity for us to get away from the workplace and to interact on a social level as well.
Engineers work across the squadron, supplies and maintenance bays in their daily work. Richard takes Tom to one of the bays he deals with often.
This is what we call exfoliation corrosion. As you can see, it also looks like a wet book. The layers have opened up there.
Has this corrosion been caused sort of mid-flight, or is this over time, or...?
This happens over time. This is quite a long, drawn-out process, and we obviously hope, this is an extreme example, that we would catch such instances before it affects the safety of the aircraft.
If the corrosion damage is outside publication limits, it is the engineering officer's job to decide whether the part is safe for use or needs to be scrapped.
The job is incredibly satisfying. You get to dabble into both avionics, stress analysis, and also general engineering in the hangar and in the workshops. On top of that, you get the experience of management, of working with people, which I think is the most rewarding. So Tom, as a officer in the Air Force and in the military, you have a number of other roles outside of your core engineering role. One example of that is a duty officer role. One of the responsibilities is the raising and lowering of the ensign. And we're going to go through now, conclusion of the day, the lowering of the ensign. The Air Force likes to grow its people into the next rank up. By getting as much experience across the board outside of engineering, it ensures that we have the capabilities of managing personnel at the next level up. It certainly is a great lifestyle.
Most interesting of the whole project was probably how everything went together at the end of the day. I mean, there's so many processes and so many people that are involved in actually putting the Sea Sprite in the air. Just the technological part of it, it's just, yeah, it's a big project.
Engineering officers undertake management and technology courses as part of their training. Engineering officers also attend both domestic and overseas courses to keep up to date with new technology. As officers, they complete a flight commander's course, which continues their training in command, leadership and management. Air Force engineering officers gain knowledge of weapons, electrical engineering, Air Force systems and equipment, as well as leadership and decision-making skills.
Supporting local content so you can see more of New Zealand on air.